You may be wondering why I'm talking about Oman. Well, I've spent quite a lot of my life working on Oman, and I like to talk about it because it's fabulous geology. It's a wonderful place to visit. It's great. I first went there in 1980. The last time I was there was 2015, with several visits in between, and I actually stopped working on Oman in 2019. So it's relatively recent. And I'm sure we have some people who have some experience in Oman, but what I'm going to talk about is a southern part of Oman, which is not so well known as the northern part. The northern part was where commercial oil was first discovered. And one of the most spectacular outcrops is the salt piercement at Karat Kibit, and it's in the middle of Oman rather than but far in the south. And you can see the porous stromatolitic carbonate that's incorporated as the salt is pushed up through all the younger sediments. Just down. That's good. Yep, we've got it. Okay, thanks. I like to look at the big screen rather than this little one, and I can stand in the middle and you can see me rather than being hidden behind the desk. Now, you can see the agenda, but that was one of our campsites on a field trip in 2011. And we were looking at the Eocene there. We looked at the whole geological column, not just the top of the Precambrian. So this was looking at it. You can see the tents that we've got, the setup of the campsite. The amusing story about this one was, that was when we arrived. And of course, we had an overnight there. And we were in a wadi, and the wind funneled down, and the lady of our team was in the first tent on the left, and she decided to pay a call to nature. The swoosh of wind came down and blew her tent away with all its contents. With your weight, it was okay because it had a built-in ground sheet, but she got up. Luckily, the truck was open, so she managed to spend the rest of the night in the truck. We found her tent about half a mile down the gully later that morning. So I'm going to give you some background on why fieldwork was done there. Then I'm going to talk about the stratigraphic framework of this area of Oman. Then go on to the outcrops themselves and the hydrocarbons, and close with some observations. That really doesn't want to work for me, so we'll go down. Right, so the field trip. I was working for a company which no longer exists. It was sold in 2016, after I left. Nothing to do with me. So Circle Oil had two blocks in Oman, one onshore, block 49, which is here onshore, adjacent to the Saudi Arabian border, and not that far from Yemen. And the other one was offshore, block 52, which is a very large offshore block, which only had a couple of wells on it. And so essentially, both blocks were poorly explored. There was lots of potential. You had existing oil fields in the area in what was, or still is, block 6, which is most of this area. And the operators, Petroleum Development of Oman, it's shell-staffed largely, Omanized, of course, but a lot of the publications are by some excellent geologists from Shell. And I'll be showing you some of their information in this talk. And why we were there was to try and tie the outcrop geology to the subsurface seismic, so we could better evaluate the prospectivity of the area and plan wells. So it was a basic step in any exploration program to maximize the availability of the data and tie it together. And the field trip was 10 days round trip from Muscat, which is in the north here, which is the capital. We went down through the middle, bit of block 49, very little outcrop there. Karaki bit, which I showed you, was here. There's another one there, Karna Lam. We visited both. and then down to the coastal area and back along the coast to an area here, which is called the Huqf Uplift. There's Mazira Island, and there's this large area of quaternary sands called Wahiba, and I'll mention it probably in closing there. It's one of the most spectacular seaf dunes fields I've ever seen in my life. They are absolutely enormous, and you can snowboard down them. I did. So, a tectonic map on the left, and the salt basins are in pink. And the South Salt Basin, which is going to be talking about most of the time, is here. There's the Gaba, and there's a Huqf Salt Basin. And the age of the salt is right at the Eocambrian-Cambrian border. It's called ARA, A-R-A. More about this, much more in detail later. The section down at the bottom is what we're going to concentrate on. And you can see there's some carbonates in blue, but the base of the section is actually clastic, lying onto granitic basement. The lower Paleozoic is largely clastic. The upper Paleozoic is largely absent. And it was probably deposited and then eroded, because you do have the odd little outcrop in there, but there's not much of anything until you get into the Permian, which the base is clastic, and there are major reservoirs in there, including Marmol. That field was discovered in 1956 by City Service. And I used to work for a company called Occidental, and they took over City Service in 1982 when I was there. And I got to know a load of the guys who were actually out there in Oman in 1956. So it was a nice full circle of things. So we worked our way back up the coast, past this area, the Mazira Trough. And in there, we have an ophiolite. There's one of two. This ophiolite was in place by abduction as India scooted past there in the late Cretaceous. And it did a sideways slip, and it banged up and over with this ophiolite. I'll show you a picture later on. The other ophiolite here is a Samael ophiolite. It's much bigger. It's in the Oman Mountains, and it's extremely spectacular. And it even outcrops in Muscat, right behind the Royal Palace. Here we have the Huqf High, which I'll be demonstrating to you with some of the rock types. And in the basin, we have some oil fields. These aren't all of them that are there. As I mentioned earlier, the first commercial oil was in the northern area. And in 1983, I was a well site geologist on a field which is now where that red dot is, called Safa. And there's a whole story there which anybody wants to question about later, I can tell you. It was very interesting. So we will be looking at the details on the Eocambrian down here. The big blow-up geological column here is for the Ara salt because it contains carbonates that have slid in there. It does. They have two carbonate platforms with a deep basin salt, and with earthquakes, rafts of carbonate floated down in the salt, and they're encased in it. And they're called stringers, and they're numbered by the drillers, one at the top, 2, 3, etc., going down. That's not how they were deposited. So the geological one is completely the reverse, and you'll see that later on. I'm just going to acknowledge Jerome Peters, who published a paper in 2003, an excellent geologist from Shell. The Maradi fault zone, which is indicated, I just highlighted it there, comes off and goes down. It's largely a lateral fault, strike slip, goes smack through the middle of the Huqf High and goes offshore. In fact, these mountains were largely placed not only by the abduction, but then as the impact of the peninsula up here into Iran, Afghanistan, bang, and that created this mountain chain. And you have lateral faults which come off it. And you will see the Maradi Fault in action soon. So let's look at the Huqf outcrops. And on the left, we have the column, and it's a supergroup, the Huqf. And so you have two main groups, the Abu Mahara at the base, which are clastics, and then carbonates with a few silty units in the middle. So in the Abu Mahara, near the base, we have the Ain Sarit, which is a potential source rock. It's got high organic content. And above that, the Mirbat sandstone. This is in the Abu Mahara. You also have sandstones above that, but very little. And these are largely glacial deposits, diamictites. And tying in on the ages, and the ages are radiometric dates. The granitic felsic crystalline basement, 840 million years, and there are volcanic ash bands scattered through the stratigraphy, which give us dates. And the dates in here, it's about 580, which ties in with the Gasquier's glaciation event, the last, basically, of snowball Earth. And that's about, it occurs in Newfoundland. That's a tight locality, but it's quite widespread. So we have the Nafun group above that. The basal carbonate unit is the Kufi, and the main constituent are stromatolites in there. And the Shura is a more clastic interval with a few limestones. And it's the Ediacaran age relating to Australia. And above that, the Bua. So you have carbonate, sort of clastic. It's, again, very organic rich. And then the Bua, all of this has got quite a lot of organic matter in it. So there's a potential oil source throughout. And the top of the outcrop, you really don't have any ara because it's been eroded off. And it's a soil. The interesting slides on here, the pictures, this was a Russian helicopter evacuated from Yemen in the civil war in the 1990s. Ran out of fuel, dumped on the beach. There's a nice little tunnel through one of the salt piercements. And here's the very modern camel train. So let's go to an outcrop. And here we come down to the coast in the Dhofar province and Wadi Hina. It's a yellow star. And we have that Mirbat sandstone directly on the granite. So there's an big unconformity there. And the Mirbat, the poor reservoir quality, because the sorting is exceptionally poor. You'll see it on the next slide. And the fluvioglacial deposits. You'll see the lat longs on these slides, which we will produce an end of field trip report. Over to Ain Sarit, just slightly inland, again, the yellow star. And there's our lady geologist, Jade, pointing to the black rocks. There they are in close-up. That was a lovely oasis around where this outcrop was. And they're sulfurous, high organic content, and potential source rocks. They've never been buried that deeply, so they're not overcooked. Here's some more of the Mirbat sandstone. And there you've got the drop stones, the diamictites, and injectites of sand. Going straight up through the section. And there is a granite wash type of sandstone over some more diamictite. The age about 580 million years, so it's equivalent to the Gasquier's glaciation. On the coast, in Mirbat Bay, again, the yellow dot. So you've seen Ain Sarit, you've seen Wadi Hina. There's Mirbat on the coast. And I'm pointing to the oil staining. There's some close-up views of it. And it's gone to tar because it's in hot sun. We were 42 degrees Celsius that day. It's pretty warm. It was March, same time of year now. And PDO, Petroleum Southern Oman, had thought, after geochemical analysis, that it was a possible Jurassic source origin for this seep. So indications of a petroleum system. Going up to the Huqf uplift. And there's a satellite photo, Mazira Bay here. There's Mazira Island. There's our yellow dot on Wadi Dungat, which is the first outcrop. I'll be showing you Wadi Shuram later on. And there's a Shuram unit overlying the Huqf stromatolitic dollar stones. They've been largely dolomitized. And there is the Permian over the top, unconformably, Alcalata, the major reservoir in the Marmol field. Why it was not developed in the 1950s was it was uneconomic, because it's not heavy, but relatively compared to other light oils. It wasn't very easy to produce. This is a schematic geological map, and the section goes through this area from west to east. Here it is underneath. The Maradi Fault, I mentioned before, is here. It's almost north-south through this area. And the Mazira Trough is off here and down there. And the hashed symbol is the Alcalata. So you can see it's eroded over the crest as well. So there've been multiple periods of erosion here. That is an outcrop of the Maradi Fault itself going along this escarpment. Here's that face. There's a person. So you can judge the scale of it. And it's magnetized with the Huqf carbonates over the Abu Mahara sandstones. Now, there's that map again with the two ophiolites, the Samail and the Mazira one. And there's a line of section which I will show you later. It's not coming now. It's a little bit later. But you will see that. And the Maradi Fault zone, it does not want to work. There is there. Onto the Huqf, so we're going up section. And you get small nested stromatolites. You can see the lens cap there. And very large ones. This one is about 1 meter high and 1 meter across. And there's a fissure in the dollar stones, bitumen filled, or evidence of a petroleum system that's working. And believe it or not, this large stromatolite had ripple marks on top of it. Very interesting. Onto another outcrop with the Shuram. And here's the Shuram cliff face. There, the Shuram overlain by the Bua. So we're getting to the top of the Nafun group. Here's that diagram again. So there's the Bua and the Shuram, Huqf underneath it. And you can see this good visible porosity in these dollar stones. And this is a potential source rock. The silts have very low angle cross bedding. So what's the depositional environment? Well, we have the Mazira Bay, which is in this area, because remember, we're going from Huqf on the south up into Northern Oman. So we're not actually particularly in the south here, so we're off the southern end of it. But it's coastal. The Huqf and the Bua are both ramp carbonates. And the Shuram, transgressive clastics with source rocks. Underneath this, in the north, remember, not the south, there is another glacial event preserved, which is equivalent to the Marinoan and a cap carbonate, the Hadash formation. But I never saw those because they were out of our area of interest. But just to the north of the Huqf uplift, in this area, blocks 3 and 4, there are oil fields in the Bua and the Huqf that have been found. Now, the PDO has not found these in block 6 yet, but I wouldn't be surprised if they did. So the operator here is a company called CC, which is an odd name, I know. And Tethys, bless them, are a partner who've put things out on the internet. And so I've got some diagrams here. And there's block 3 and block 4. They have a central production facility called Salwan. And there are several fields around. And Ulfa and Samha are anticlines. that have Bua and Kuphite carbonates. And remember what I said about lateral faults? That's why you get anticlines. It's strike slip movements, a bit like California, different direction. There's another one, Irfan. And Ulfa and Samha are here, and Irfan is down here in block 4. There's no R assault. It's down dip, and you'll see that on the cross section coming up. So we'll go on down, and that's a cross section I keep promising you. So it goes from northern Oman across the Fahud salt basin, across the Gaba salt basin into the Huqf uplift, which is here. The Maradi fault zone is there, which is this fault which comes down. And the R salt is the pink unit. So it's in Fahud, and it's in the Karnalam field, which I will show you in just a moment. But that's the reservoir in Karnalam, which is the top of what's known as the Nati. And we have other fields in that low Cretaceous unit. And we have other indications with gas down in the Carboniferous. So it's quite an oily system. The flag symbol is for source rock. And this is taken from one of the PDO papers. So you can see a big regional cross-section there coming up to the coast. Onto the salt, Ara. And we went to see the 2 salt domes of Karat Kabrit and Karnalam. There's Aweeba Sands, there's Muscat. So we're dealing with this area, the Gaba salt basin. There's an aerial photo of this salt diapir. And there it is, similar to the first picture I showed. And we have salt, and we have carbonate stringers, and we have black shales. There's the salt. There are also anhydrites in it, but most of it is halite. And there's some of the carbonate stringer, which has super pinpoint porosity. And there is some black shale, which has up to 7% total organic carbon. So it's a good source rock. Onto Karnalam. There's the outcrop, aerial photo, and some of the stringers. It's quite spectacular territory. And there's a seismic line across it. So you can see the salts come up, and this amorphous area in the middle is where the salt's gone through. And Nati is the main reservoir in there. Here's a stratigraphy of the Ara group, which showed you a little earlier, but there's more detail here because we've got in the south a carbonate, in the north a carbonate, and in the middle a deep basin. And within that deep basin, we have a very unusual rock. It's called a silicilyte, and it's a chert, basically. It's chert, silica, but it contains high organic matter content. And there it is in the deep basin, Al-Shumu silicilyte. There you can see the geological nomenclature for the stringers. 6 at the top through to 1 at the bottom. As I said, the drillers drill from the top down, so they number it the other way around. Another reason why geologists and engineers don't get along very well. More of that later, if you ask. Yeah, this is in alternating salt in pink and blue in carbonate. And there are a few little clastics in there. But in the deep basin, we have a silicilyte. And in the eastern margin, more solid carbonates throughout. You'll notice the naming in the stratigraphy, we've got Berber. And I'm going to show you what the Berber discovery is like. And it's in about here in the southern basin. There we have a map showing you discoveries in the area. And Berber, there it is. That's where Berber is. Harwell is down here, and that's another one. But the first discovery was Nasir, which is that well there. And just close by it, Berber. You can see the cross section here. There's Berber, there's Nasir. The Berber 1 well was just a year after Nasir. And the test in Stringer 1, which would be A6, in geological nomenclature, tested 9,000 barrels a day. Very impressive flow rate, 27 API. There's actually a lot lighter than that as well. So there's the cross section to show you what these blocky carbonates look like in detail, interpreted from the seismic. What we liken them to were sausages, because that's the way it looked, sausages that fell down, slid through the salt and stacked on top of one another. So they get all these stringers and they're all contorted, but they're sealed in salt, the perfect seal. You have to spot them on seismic to get it right. And the log response, you can see salt here, and then the carbonate response in here. They're very blocky reservoirs. This is the Harwell discoveries, and they're all tied together. All these discoveries are tied together for production facilities. There's a scale, it's in here. And this is the seismic. So you can see they look like sausages tumbling down. And there's a cartoon of them tumbling down in the hour salt. And notice you get the infill at the side of the younger sediment, infilling the gap between the salt swells. And the source rock down here, but there's also source within the Ara itself. I showed you the black shales. Now we're going to go on to the silicilyte. Originally drilled the well that was mapped for the stringers, a structural closure. The well was Al Noor in 1989, but it encountered 505 meters, very thick, of organic rich cherts with a 50-meter net pay interval. And it tested only 188 barrels a day after acidization. Later on, Al-Shomu, so there's Al Noor, there's Al-Shomu. Again, a structural closure, but it was mapped for the silicilyte, and they knew what they're doing by then. Just over 300 meters of chert, and tested 533 barrels a day, but they stimulated it with warm water. And this is what the rock looks like in thin section. And here's a backscattered electron image, and this is an energy dispersive image. The blue is the oxygen in silica. Green is organic carbon, and there's quite a lot of it. The red, there's a little bit of it. It's the aluminium in clays, and the yellow there is the sulfur in pyrite. So the organic matter, its sterines were thought to be from demosponges, the spicules of opaline silica. But it forms basically a chert. And the map here shows the southern platform, the northern platform, the deep basin in between, and we have accumulations of oil in structural closures in the silicilyte on blocks, on interbasinal highs. And to get the oil out, they've had to drill long reach wells and frack them, massive hydraulic fracking. But the primary recovery, and so they do need to do the fracking. The porosity can appear large, but the permeability is very low. So that's why you have to frack them. Total organic cavern in some of them is 4%. The oil itself is sour. It's got hydrogen sulfide in it. It's overpressured with hydrogen sulfide. It's nasty stuff. Although it's light oil, it's not very nice. The oil is in the stringers comparatively is a little lighter, but it's a little heavier, but it's still very light at 37 API. So that's that strange rock, the silicilyte. I've never come across it anywhere else in the world. What has it done for Oman's economy? It's been great. You can see the rate of increase in production storming up. Number of wells storming up. So the cumulative production has been tremendous. And in Block 6, from 1997 to 2002, discovery was over 1.6 billion barrels of oil in place. Been very successful. PDO have carpeted that block with 3D seismic. It's a great effort that they've done. And this is a sketch section across Southern Oman, going from west to east from Block 49, if you remember that block, through Block 6 to Block 52. And you can see the Ara stringers in here. There's Marmul with the oil primarily in the Permian and a few other rocks as well, because it's actually it's a salt withdrawal feature that's been infilled by younger sediment, and it's because you have further salt withdrawal, it's left a hump in between. It's called a turtleback structure. That's what it is. So your source rocks and a seal, terrific. Block 49 remains an enigma. I can tell more about that if you will question me. And Block 52, similarly. And I have another story to tell about that at another time. So, observations. World-class outcrops of Eocambrian to tertiary sediments, basically 600 million years of rock record. It's one of the oldest working petroleum systems in the world, in the Huqf. And the reservoir rocks range from glacial clastics to marginal marine stromatolitic carbonates. The traps can be conventional fault blocks, wrench-faulted anticlines, and rafted carbonates, those stringers. And despite almost 70 years of exploration, there's many opportunities to discover additional reservoirs and traps. So here's a couple of my mates, and down the bottom, that's the ophiolite, the Mazira ophiolite, this very dark black-green rock, Harzbergite. Above it is Ubar-Shiza, which was discovered by Ranulph Fiennes, or rediscovered, shall we say, the explorer. And they've done a little bit of reconstruction in this very, very old site. It's rumored, no proof, to have been one of the sites where Queen of Sheba lived. We don't know that. That's what it's about. There are the big dunes in the Wahiba Sands and the snowboard. And there is one of the outcrops where the Cretaceous Aptian age Kishan plastics and carbonates, the carbonates Aptian age, sit on top of the Eocambrian, the Abu Mahara. So it's quite an unconformity there. So, what have you got to say, guys? So, a little poem for you to finish off with. A great tourism locale lies in Oman. Geology and environment both interact. Culture and heritage, their fine synergy lives on. World-class outcrops, huge mountains, desert dunes. That's a fact. Ubar-Shiza, ancient town way down south in Dhofar, where summer monsoons bring rains that turn the coast green. Oryx, ibex, and Arabian leopard live there. Muslim and Portuguese invasion ruins can be seen. Dark rocks of mid-ocean volcanics are exposed, thrust over younger limestones in hilly terrain. Beware exploding wadis, where flash floods may transpose, but visit the land of natural beauty and harmony retained. So, thank you very much. I'll take questions.